to all. This is S. Muthukumar from Department of Mathematics, K.S.Rangasamy College of Technology. In this video, I am going to explain about the formation and solution of a recurrence relation. Recurrence relation is nothing but a difference equation. A recurrence relation for a sequence an is an equation that expresses an in terms of one or more of the previous terms of the sequences. If a sequence satisfies any recurrence relation, then it is known as solution of that recurrence relation. This is the example of a recurrence relation. Here an is expressed its previous term an minus 1 plus 2. Now see the formation of recurrence relation. Find the recurrence relation for the sequence Sn. It is defined as 6 into minus 5 whole power n. Here n varies from 0 to infinity. Now find out its previous term by replacing n by n minus 1. Therefore S of n minus 1 equal to 6 into minus 5 whole power n minus 1. Now simplifying these terms, we get the answer as 6 into minus 5 whole power n divided by minus 5. So this numerator term is equivalent to the given function s of n. So replace s of n here. Therefore s of n minus 1 equal to s of n divided by minus 5. Its reduced form is s of n plus 5 into s of n minus 1 equal to 0, which is the required recurrence relation for the given function with the initial condition s of 0 equal to 6. This can be obtained by replacing n equal to 0 from the given relation. Now the second problem. Find the recurrence relation for the sequence an equal to 2n plus 9. Here n greater than or equal to 1. So its previous term is an minus 1. So replace n by n minus 1. 2 into n minus 1 plus 9. This 2n plus 9 is equivalent to an. Therefore an minus 1 equal to an minus 2. Its rearrangement of the terms are an equal to an minus 1 plus 2 n greater than or equal to 1. Here the initial condition a not equal to 9 obtained from this equation by replacing n equal to 0. Based on the given recurrence relation, it is defined into two categories. If the given recurrence relation contains the term f of n, then it is known as linear non-homogeneous recurrence relation. Otherwise, it is known as linear homogeneous difference equation. Based on this nature, we can find the solution for the recurrence relation. Now the problem is solve the recurrence relation y of k minus 8 into y of k minus 1 plus 16 into y of k minus 2 equal to 0, where k greater than or equal to 2, with the initial condition y of 2 equal to 16 and y of 3 equal to 80. Now check the order and the nature of the given difference equation. The difference between these two terms, this highest difference and the lowest difference is 2. So it is a second order difference equation. And also there is no f of n term in the given equation. So it is a linear homogeneous equation. For this type of equation, the general solution for the recurrence relation is the complementary function only. So for that we need the characteristic equation. The given equation is y of n minus 8 into y of n minus 1 plus 16 into y of n minus 2 equal to 0. So it is a second order equation. So we can form a characteristic equation in quadratic level. That is r square. This is the highest difference term. R square. This is the next one. Minus 8 into coefficient into r plus this is the first term. 16 equal to 0. Now factorize this equation, which gives the results for r equal to 4 and 4, real and equal value. Therefore the general solution for the given equation is alpha 1 into r power n plus alpha 2 into n into r power n. Here n is used for the repeated values. Now replace r value here. So alpha 1 into 4 power n plus alpha 2 into n into 4 power n. Next to find out the value of these constants alpha 1 and alpha 2 by applying the initial conditions. The first condition is y of 2 equal to 16. That means replace n by 2 in the general solution of the given recurrence relation. So y of 2 equal to alpha 1 into 4 power n, that is n equal to 2, 4 square plus alpha 2 into 4 square. So which gives the equation alpha 1 plus 2 into alpha 2 equal to 1. Next apply the second initial condition to the same equation. That means substitute n equal to 3 in the equation number y of n. So the reduced form of the equation is 4 into alpha 1 plus 12 into alpha 2 equal to 5. Now solve the equations 1 and 2 to get the values for the constants alpha 1 and alpha 2. For that multiply the first equation by 4 and then subtract 2 and 3. Then the answer for alpha 1 equal to 1 by 2 and alpha 2 equal to 1 by 4. Now replace this alpha value in the general solution. Therefore the required solution for the given difference equation is y of n equal to 1 by 2 into 4 power n plus 1 by 4 into n into 4 power n. Now see the second problem. Solve the recurrence relation s of n minus 3 into s of n minus 1 minus 4 into s of n minus 2 equal to 4 power n. It is also second order equation since difference between these two terms is 2. So it is at second order. Also the right side term contains f of n form. So it is a linear non-homogeneous difference equations. This type of equation contains two different solutions. The general solution of linear non-homogeneous difference equation is defined as an equal to an solution of homogeneous equation plus the solution of particular solution. So first find out the homogeneous solution, homogeneous linear equation solution. For that assume that the right side term is equal to 0. The characteristic equation corresponding to the homogeneous linear equation is r square minus 3r minus 4 equal to 0. Therefore the solution for homogeneous form is alpha 1 into r1 whole power n plus alpha 2 into r2 whole power n. Here r1 equal to 4 and r2 equal to minus 1. Next to find out the particular solution. Here f of n equal to 4 power n. the base is 4, which is the one of the root of characteristic equation. Therefore, assume that the solution for the particular solution is in the form of Cn into 4 power n. An equal to Cn into 4 power n. So using this result, find out the values for an minus 1 and an minus 2. Here an equal to Cn into 4 power n. Here replace n by n minus 1. So C into n minus 1 into 4 power n minus 1 minus 4 into a power n minus 2. So replace a power n minus 2 by C into n minus 2 into 4 power n minus 2 equivalent to 4 power n. Now simplify these equations. From that we can get the value of C. Here C equal to 16 divided by 20. That means 4 by 5. Therefore, the particular solution for the given equation is an equal to Cn into 4 power n. Here replace the C value 4 by 5 into n into 4 power n. Finally, the general solution for the given linear non-homogeneous equation is an equal to homogeneous solution plus particular solution. That means alpha 1 equal to 4 power n plus alpha 2 into minus 1 whole power n plus 4 by 5 into n into 4 power n. Here the initial conditions are not given, so we cannot calculate the value for these constants. Thank you.